The Discovery of X-rays, Unit 14, Lesson 2. The boys gathered around the picture. There was no doubt about who owned the sour look. It was a perfect caricature of their schoolmaster. The boys laughed and complimented the artist on his work. Willem Conrad Roentgen was laughing so loud he didn't hear the schoolmaster coming down the hall. The door opened, and Willem found himself looking into the same sour face he thought so funny a moment earlier. Turning around, he realized he was the only one standing by the picture. Knowing Willem couldn't draw, the schoolmaster asked him who had made the caricature. William looked at his classmates, then back at the schoolmaster. "I can't tell you, sir." Furious, the schoolmaster was determined to punish someone. Unable to find the real culprit, he convinced the faculty and director of the school to make an example of Willem. As a result, the boy was expelled. Willem couldn't believe it. Without a diploma, he couldn't go to a university, and without a university education, he couldn't become a scientist. But Willem refused to give up. He began attending classes at the nearby university at Utrecht, the Netherlands, even though he wasn't a regular student and couldn't graduate. There, he met a man who told him about the Polytechnic Institute in Zurich, a Swiss university that would accept students without diplomas. Willem's hopes soared again. When Willem arrived in Zurich, he found that he could begin classes without taking the entrance exam because his mathematics grades at Utrecht had been good. With what he called secure academic terrain under his feet, he began to excel. In just 3 years, he graduated with a degree in mechanical engineering, and the following year he earned a PhD. Willem was a scientist at last. He taught and did research at several different German universities, his reputation growing as the years went by. While he was professor of physics at the University of Würzburg, he made a fascinating discovery. On the evening of 8th November 1895, Willem was experimenting in a darkened room with a Crookes tube, a glass tube with all the air pumped out of it. While watching electric current flow through the vacuum tube, he saw a glow emanating from the chemical coating paper screen lying on his workbench. The closer he brought the screen to the tube, the brighter it glowed. Willem put a book between the tube and the screen to see what would happen. The screen still glowed, but not as brightly. He began to put anything he could find between the tube and the screen. He tried books, rubber, foil, a double deck of cards, wood, glass, and water to see how they affected the screen's glow. The screen varied in brightness with each item. He held a piece of metal between his fingers and was horrified to see the outline of his bones on the screen. Willem hypothesized that the tube was producing invisible rays powerful enough to penetrate even human flesh. He was witnessing something that had never been seen before, a new form of energy. Since X is used in mathematics to symbolize an unknown, William called his discoveries X-rays. Willem told no one about what he had found. For 7 weeks he experimented with X-rays until he was satisfied he knew their basic properties. Then he announced his discovery to the world. Within a week, the news had been cabled all around the globe. People everywhere were amazed by the mysterious rays and wanted to know more about them. Tall tales about X-rays soon spread. When people heard that the rays could pass through clothing, they were afraid others would be able to see them naked. As a result, a shopkeeper in London advertised X-ray-proof underclothing to protect his customers' modesty. In New Jersey, a legislator introduced a bill that would make it illegal to use X-rays in opera glasses at, at the theater. Some hopeful alchemists claimed that X-rays could turn cheap metals into gold. It was even rumored that a medical school used the rays to place facts in the minds of its students. Though none of these things are possible, the stories kept growing. Doctors soon realized, however, that X-rays could improve their practice. Using Willem's rays, they could see if a bone was broken or find the position of a bullet. Still, most people were terrified to see pictures of the insides of their bodies, and patients often fainted when they saw X-rays of themselves. William Roentgen received many honors and awards throughout his life, and in 1901 he was awarded the first Nobel Prize for Physics for his discovery. but he gave the Nobel Prize money to the university and shunned the fame that seemed to seek him out. Though his name quickly became associated with various Roentgen societies, and though in many places the study of X-rays came to be known as Roentgenology, Wilhelm continued to busy himself with academic pursuits and refused to exploit his status as a father of the X-ray. As a scientist, Wilhelm believed the X-rays belonged to the whole world, therefore he refused to patent his discovery. Today, X-rays have many uses. In medicine, not only do doctors still use X-rays to find bullets and broken bones, they are used to diagnose diseases and fight cancer. Airports use X-rays for security, and large pieces of steel and industrial equipment can be X-rayed to find microscopic cracks and internal faults that can't be detected any other way. Astronomers study X-ray emissions from distant points in space to learn about quasars, black holes, and the remnants of supernovas. Archaeologists use the rays to see inside mummies without having to unwrap them, and art historians can X-ray paintings to see the techniques of long-dead artists. From helping doctors treat their patients to protecting people as they work and travel, X-rays are an important part of business, industry, medicine, and science around the world. William Conrad Roentgen's discovery a century ago is one of the most important and most widely used of all times.